Mounting a front fender, or mudguard depending on where you are, on a bicycle shouldn't be rocket science, and it isn't rocket science. Yet you might find that in some bicycle shops the task of mounting a front fender properly clearly overwhelms the capabilities of the personnel working there, who do manage to mount the front fender both crooked and untrimmed down here if it's such model. So that's exactly the case that we have right here. So you might as well just mount the fender yourself, or in a completely independent, unrelated scenario, a perfectly fitted and mounted front fender might need periodic adjustments for two reasons. One, there might be a loose bolt rattling on it somewhere and it needs tightening, and while it's being tightened, the fit of the fender needs to be checked and ensured. Scenario number two, you might switch to a different tire, such as going from a road tire to a gravel tire. The gravel tires are knobby, they usually have a taller sidewall height here, and the clearance between the gap between the fender and the tire needs to be a healthy amount here, so that the tire is not being caught on any part of the fender here, the bolts or whatever. Whatever the occasion, either adjusting the fender or mounting it, in this video I'll show you the tools needed and the geometry involved in mounting a front fender right. Let's get started with the tools. And I recognize you may have different models, not necessarily this particular model here that I have, and I really don't have a model designation. All I have is a little emblem down there. So all fenders somewhat look alike and work out to be alike, and their geometry is somewhat all similar. So I'm gonna have options here with tools, and we'll mention some design differences between different models. So let's get started with the tools. Very simple, inexpensive hand tools is all that's usually required. I have a run-of-the-mill Phillips No. 2 screwdriver, just like so. Nothing so special about it, other than it's not chipped, busted, broken. It's dimensionally properly fits. It just happens to fit that one bolt there that has a hanging bracket. I'll take it all off and we'll show you close-ups of everything. I have two very simple wrenches or spanners depending on where you live. One of them is an 8mm shiny or a 10mm not shiny, matte surface. This one, the shiny one, is forged and is an automotive wrench, dimensionally more accurate than this very cheaply made stamped 10mm wrench, which came out from probably a motorcycle's toolkit that the manufacturers include, and they make it cheap, and so this is a stamped tool. You know, in this particular scenario it fits that bolt down there at the wire stay. This is the wire stay on the mudguard, and that's where it's going to be used. It's close enough, it tightens that bolt necessarily enough, and this one fits here as well, because this fastener here has corners that you can fit a wrench on. So with the wrench, tightening and breaking the torque on fasteners, and because this particular bolt there is, I don't know, 2 centimeters long, about 3/4 of an inch, whatever, the rest of the distance can be, you know, easily traveled with a screwdriver. It's a lot faster with a screwdriver. And however, this could also work for tightening it, you know, the last quarter turn or half a turn, but this is not a torque wrench, and we're going to talk about torque in just a minute. The last tool that I need is in the fork leg here for that bolt there, and I have a matching one where these wire stays are being held, and the best fitting tool, hand tool, is this one, just a hex key, or also known as Allen key, with a hexagonal cross section. Of course we have different options. You can have a whole set of these with different sizes, 4mm, 3mm, 2.5, 2, 1.5, and some more on the other side. But this shape is too long. It doesn't fit between, even with the wheel removed, doesn't fit between the fork legs. and so this one has some limitations. I'm gonna get rid of it there. And of course there is this kind automotive style hex key as well. Now the problem with this, that these tend to be over tightened, over torqued. So let's talk about the fasteners for a little bit here. This one needs a 3/8 ratchet that goes here, a ratchet handle, but what you are actually going to need is a 1/4-inch drive and a short torque wrench, because the forks are made of carbon fiber or aluminum, either which way, thin-walled items. And I recognize some bicycles have forks that are still tubular steel that taper to a narrow point and have a little bend towards the end where the axle goes through. And the steel can be just mild steel or could be chrome molybdenum steel. Especially the aluminum forks, and this is a carbon fiber forks, are constructed differently and are affected the following way. If you over tighten the steel bolts, the thread is going to be stripped out from the fork leg. The tightening specification is not printed anywhere on the bicycle, and the fender manufacturer doesn't include any numbers. But if we look around on the bicycle a little bit looking for numbers, you might find on the steering stem here, where the handlebar clamp bolts are mounted, a figure 5 Newton meters. And over here at the seat post, where the seat post clamp ring is, this one, 5 Newton meter figure is also printed on it. 5 Newton meters is a metric number and is a very low amount of torque. The equivalent of it in terms of imperial units is 3.68 foot-pounds of torque. It's a very low number. 3.68 foot-pounds is, in terms of inch-pounds, is 44¼ inch-pounds. So it's a very, very low number. The handlebar clamp bolts are a structural connection, and that one also is a structural connection. The fender is a trim item. It only needs to stay in place and hold, mostly against rain, a little bit of splash. It's not a structural item, it's a decor or trim item. So 5 Newton meters of torque, or 3.68 foot-pounds of torque, or 44¼ inch-pounds of torque is plenty. Do not over tighten, especially these 3 fasteners on this particular model, or any fasteners going into carbon fiber forks. When the carbon fiber forks are made, or the aluminum is cast, they are made in a way that the threaded inserts are already in place on the inside of the fork leg. Okay, that's an insert that they place purposefully into the mold, and they put the fiberglass layers, and they put the resin and the hardener on it, or in case of aluminum, the molten aluminum is being poured around it. If you strip out the threads from this one, good luck heli-coiling it and making it bigger and enlarging it, and especially it's not possible to drill another hole next to it and hoping that the new hole that's above it or below it or in front or behind, if you drill a new hole, to be able to cut thread into it that would accommodate the same size of screw, because the sidewall of the forks are so thin that you're not going to be able to tap the hole that you drill into it. Okay, it's not happening. Plus, I forgot to mention, good luck drilling it in the first place, because you can't fit a drill on a fork leg from the inside on straight. There is no such length of drill bit that with a chuck and whatever that would fit there. So don't strip out the threads. Okay, 5 Newton meters is plenty. Whatever tools you use, whatever quality and brand the tools you're considering, probably a good idea is having a torque wrench calibrated in Newton meters, a low level not the 2-foot long torque wrench that you use for tightening the lug bolts on the wheels of a truck. No, a cute little 6 or 8 inch long torque wrench calibrated in inch-pounds and low numbers of Newton meters. So that 5 on it is not just barely out of the adjustable range, it should be clearly on it. So that's that. On some models, this wire stay, the last set of tools that you need, is gonna be needed on this wire stay. Like this one here is just ending blindly here. On some models it loops around, not on this one. So because of a proximity here, a closeness here to the bicycle's pedal and the possibility of a toe strike, I'm gonna get you close up on this one. This needs to be cut. Capping it with this rubber cutesy little cap that goes on the end of the wire that is now subject to repeated toe strikes is not going to cut it. So it's not the solution. Solution is that this needs to be shorter. When you cut it, you have again options. Of course you're going to need a marker or a permanent felt-tipped pen or something to mark its length, accommodating a road racing tire which has even shorter profile, sidewall height, a touring tire which has somewhat taller sidewall profile or sidewall height, and a gravel tire which is even usually sticking out even further out from the rim, given identical sizes of tire. Okay, so whatever your rim size, so the fender needs to be pulled out to accommodate for gravel tires, and wherever you're happy with the length, you're going to need to make a mark. So that's that. Once you have a mark, of course you're going to need to mount the fender twice. Once a test fit to make sure that it's mounted properly and that you have the length correctly marked, and then take everything off, take the wheel off, and then cut it. So you might cut it with a simple bolt cutters like this, hand tools, or you might cut it with a hacksaw, just hacksaw it through, or you might cut it with my personal favorite is this cut-off disc from a power grinder. Now, so this is not a grinding wheel, this is a cut-off wheel. Either which way you cut it, there is going to be some burrs created on this wire stay, and it's going to need some filing. Not the 12-inch horseshoe file or X file, not the 10-inch one, this cute little 6-inch file, because the teeth are getting finer and finer. Not a needle file, the jewelers use, whatever, you know, something in between. So a hand file is going to be needed on this one to round it off. Now the length of it should be, like I said, enough to accommodate a gravel tire. Let me just take you off the tripod and get you a close-up here. And you can see how this is going through. This is a clamp bolt on it. How it's going through the clamp bolt and going through the bracket there. So it should be cut off somewhere here, for example, if I'm staying with the same size of tire. But for the gravel tire I might want to add just a little extra to it, something like that. So this extra length here is gonna give me enough clearance between the fender and the top of the tire, so the tire is not hitting, the edge of the tire is not gonna be hitting the bracket here. Usually this is the pinch point here where the tip of my finger is. So I'm going to show you this bolt close up. I'm going to take it off, and I'm going to take off that bolt. We'll show you a close up on it, and we'll explain the geometry of this fit, how this works when it's crooked versus when it's straight, or what it takes to make it straight. Before I loosen any more bolts, let me just show you how it looks like when it's mounted crooked. And this may or may not annoy you, because I'm staring at it when I'm cycling. This is annoying me. Okay, so this is where it should be, and this is where it was mounted when it came out from the dealer. Okay, so this is not rocket science to adjust it, just a little bit of patience. So the 10mm bolt. Oh, side note here, when you tighten this clamp bolt here, the 5mm torque specification is not nearly as crucial because this is a steel clamp bolt, a steel nut on a steel bolt. But there's no reason to over tighten these, and by over tightening this or substantially tightening this clamp bolt here on the wire stay is not going to make the fender straighter or better fitted. Okay, so 5 Newton meters for everything is it's close enough approximation. And disconnect it like so. That's nice there. So this one here has, I forgot to mention, a nylon insert, a threaded or a nylon insert at the end of the threaded length, and just works like this. That's all there is to it. The bolt doesn't have a traditional bolt head, just has a hole through which the wire stay runs. So that's that. And the bolts going into the fork legs as well as that one, blue thread lock compound. Okay, not on these ones with the nylon insert, but on those ones. Okay, don't forget the blue thread lock compound. Now let me just show you one thing here with the fender before I completely take it off, that this is what's affecting straightness. Now it's just free hanging and it's still not kind of straight enough, but you can see how it's being adjusted. I'm moving it, doing this there. So what that tells you is that straightness of the front part of the fender is created with rotation here. You can see I'm rotating this. This rotation is made sure here along the wire stays. Let me just take off this bolt here. You can see there's maybe a morsel of blue thread lock compound left on it. Maybe if you look at it really hard. Alright. So on these brackets here, this is where these wire stays run through. If the length of the wire stay is not identical on left side and right side, which is gonna equal to asymmetry in terms of this fender being slightly rotated, that's going to make the front go either to the left or to the right. It's just that simple. Okay, so this is the major point of control for making the fender straight. Okay, very simple. One more thing you need to check is this bracket for straightness and flatness, because this also affects mounting the fender that's straight on. Let me just show you the geometry there with this square. Now nothing is square in terms because of the curvature of the fender, but you'll see it has to be still flat and square. I'll show you how. If you look at it carefully, this one isn't, and I didn't want to straighten it just yet. You can see that it's bent, and if I put the square to it, in this case I'm just using the square as a straight edge, you can see it's gappy, you can see the light through it. It shouldn't be bent. Okay, this is has a high point somewhere here in the middle. On the other side of it, I have a similar situation where deformity is even more obvious right around there. Okay, you can see the gap under the edge of the ruler. One more way to check it that this is square is done this way. The edge of the fender is assumed to be straight and even, like so, and the bracket should be square this way. This is hard to make it fit there and film it at the same time, but you can see that this bracket is twisted. You can see if I take it off from the edge, you can see that the bracket will lie flat this way, so the bracket is twisted slightly there. Okay, I hope that makes sense. You can also check it from, of course, this way. You see that the bracket is twisted, so that's also affecting the straightness of this part that I am staring at when I ride the bicycle. So this bracket and the length of the wire stay down here, both contributing to this fender being crooked or mounted crooked. Okay, so that's the geometry that's involved. Last little close-up that I want to show you concerns this toe strike here. I'm just gonna just gonna reset right about there. You can see the pedal here as close as possible in this position to the end of this wire stay. Oh, side note, if the 5 Nm torque doesn't allow you to hold the wire stay in this fixed position, don't worry about it. The 5 Nm of torque doesn't have to be clamping the end of the wire stay too much. You should be able to adjust up and down fairly easily, like so. So it's okay if it rotates a little bit around the screw or bolt head there. So going back to this toe strike, this pedal here that I have has works with a clip-on shoe, where the clip-on shoe clips on. I moved the clip on the shoe as close to the toe as possible, so my toe only projects forward the least minimum. But you can see that at this point, when the crank is in this position and the wire stays sticking out, the toe on the shoe literally strikes the ends of the wire stay. So that's again one consideration that you might want to be looking at. How far the fender is being pushed forward and how close it is overall to the tire and how much clearance you have. The shorter clearance you have, the less likely it is that you have this toe strike situation. Now this toe strike is not the fender's problem, it doesn't originate from the fender. It is a distance between the front axle there and the center of the crank there. So it has to do with the length of the crank, has to do with the length of the fork, has to do with the angle of the fork, the rake angle, and has to do with the overall size and geometry of the bicycle as well. So this toe strike may or may not happen on your particular make and model of bicycle, and manufacturers of course make sure that the rider doesn't ever kick the tire, but the fender might be in the way. So trying to blame it on the fender is not going to work when it's an inherent issue with the bicycle's geometry. Alright, so sometimes or in some cases to mount a fender on top of a gravel tire may not be entirely possible to avoid toe strike. Okay, so that's a geometric limitation that you're going to have to consider as well. There's no way to eliminate that toe strike in some models. So that's basically what I wanted to share about this geometry of the front fender mounting. It's not rocket science, but it can be taking quite some time to experiment where exactly this should be mounted so that it works for everything, works for the toe strike, works for the biggest gravel tire that you want to mount on this rim, and works for straightness as well. It needs a little experimentation, and give yourself lots of time. Thank you very much for watching.